Ciao friends! In this video, we will see the row context described in a visual way. Yes, we can provide a graphical representation of the row context to help you getting a better idea, a better visual description of these fundamental concepts in DAX. In a previous video, we introduced the filter context. In this video, it's time to look at the row context. Let's start with the demo. We start with the classic example with contoso and sales amount, because we want to look at the definition of the sales amount measure. In this report, we have just sales amount by brand and color. We're more interested into looking at the definition of the sales amount measure, because here we have two important elements of the DAX syntax. We have two column references, sales quantity and sales net price. This measure is saying multiply the quantity by net price in each row of the sales table and sum the result. But when we look at the definition, of the part of the syntax, which are sales quantity and sales net price, we have two column references. A column reference is a syntax that says, give me the value of this column from this table in the current row. In this case, the quantity column and the net price column from the sales table. But what does it mean in the current row? The current row references what we call the row context. The row context is the second important conceptual element of the evaluation context that we have in DAX. The first one is the filter context we described in a previous video, also in a visual way, and now we're going to describe the row context in a visual way. What does it mean? Well, when we have a table, in this case we have the sales table, we have a table that has columns and rows. The syntax we have now, the column reference, is just saying, give me the value of the quantity column of the sales table. Now, when we look at the table sales, and I have a simpler representation here of the sales table, we can recognize a specific row of the table. And when we have an iterator, like for example, the sum x over the sales table, we have something that scans the table row by row. And for each row, we obtain what we say the current row. But how can we represent this in a conceptual way? We have two techniques we can use. One is that we can just highlight a row as I did now, or we can imagine to do something similar. Imagine that you extract just one row of this table, and then you also get the header of the table. What do you get? You get a table that has the same number of columns and just one row. So another way to see the row context is just the extraction of a single row from the table. And so we can say that when we have a row context, we have a table that has only one row. The content of the table is the row that was the current row during an iteration, during an operation that iterates, that scans the table row by row. What does it mean? Well, when we consider the sales table, well, what we get is in a table that has, for example, 3 rows, we get exactly 3 row contexts. And so when we scan the table, we have for the first row a first row context, then for the second row a second row context, and so on. You can imagine that during the iteration, row by row, we create these new tables. Each table has only one row. So this is a way to look at the row context. It's just another table. And we will see later that this concept can be very helpful when we have to introduce another concept in a future video, which is the context transition. And the question is, when do we get a row context? Because of course, the row context is something that I'm describing now, is something that we obtain because we are using sum x. Now, sum x is one function that iterates a table, but how can I know if a function is going to generate a row context? Because only when you have a row context, you can write a DAX expression that includes a column reference like I did here in sales amount. Here in sales amount, I have sales quantity, sales net price. If you try to write this syntax in an expression that is not that doesn't have a row context available, this expression will fail, will produce a syntax error. In this case, it doesn't fail because this second argument of some x is an argument that has a row context. How can we know that? How can we check all the functions that have that? Well, one idea, one solution, one possible tool we can use is the website DAX Guide. In DAX Guide, we have a guide to all the DAX functions where we can see a number of information. But if you want to know which functions have actually the ability to produce a row context, what we can do, we can filter those functions that have an iterator, or as an option, those functions that have a parameter that includes a row context. But because every iterator also has a row context, they are pretty much the same thing. You see that now, by choosing iterator, I have highlighted only a few functions, like add columns. If I click on add columns, I can see the parameters of this function. And if I remove the filter, if I click the filter here, I can see only the DAX functions that iterate a table producing a row context. Now, you see here that in the help provided by DAX Guide, we have important information like the tag iterator, which identifies the table that is iterated row by row, and the expression with the row context, which is the parameter that has a row context. So in that argument, in that parameter of the function, you can write column references of the table that you are iterating, the table that you passed as an iterator. So this is the way you can understand the syntax of DAX and figure out when you can use a column reference and on which tables, of course, you can use these column references. Now, let's try to describe what happens, because actually, at the end we have the row context, but we also have the filter context, and the filter context actually doesn't impact the expression executed in a row context. However, is the interaction between these two elements that produce the final result that we have. So if we go back to our report and we analyze the sales amount measure, we can say, okay, how does it work? How sales amount produces the final result that we see here? We have both the filter context and the row context that work together. And we can see this step by step by using this representation. So let me try to describe what we have here. So let's start just with these two elements. So of course I'm trying to simplify here because I need to go step by step and I want to use a smaller number of elements. But in this case we have a table, the table sales, that has several dates, several order numbers, several product keys. And let's say that we introduce in the filter context, so let me highlight this part. In the filter context we apply a filter on a single day. Okay, so we filter one date only. Now, what does it mean? In a filter context that filters only one day, we're going to filter only those rows in the sales model table that satisfy the condition of the filter context. So in other words, the table sales, the table in the model has all the rows. But when we write in DAX a table reference, the name of the table sales, what we get is actually only the list of the rows in the table in the model that satisfy all the filters that we have in the filter context. So if we zoom this a little bit, so let me remove this, and we look at the definition of the measure sales, the measure sales amount, where we iterate sales, we see that this sales, sales table reference here is doing what? Well, this table reference is actually referencing, let me just reduce this a little bit. This table reference is just referencing this table. The table, the sales table reference that we have, has only the rows that satisfy the filter. So in other words, the filter context is something that gets at the table and produces the result of the rows visible through the filter context. That is what we get with the sales table reference. So first of all, when we write our sales amount measure, SUMX iterates only the rows in sales visible through the filter context. So this is the first step. At this point, on this sales table reference, row by row, we have the iteration over the visible rows. And for each one, we have a row context. So the first row produces this filter context. The second row produces the first row context. The second row produces the second row context. And so you see that this is what we have. So in other words, we start from the model table has all the rows. The table reference returns only the rows visible through the row context. And the iteration row by row produces like a small table that has all the columns, but just one row, the row that we are iterating at that moment. So for each row, what happens? Well, in each row, we have the execution of sales quantity and sales net price. So when we are iterating the first row, we're getting, let me move this here, we're getting the sales quantity here and the sales net price here, first row. Second row, the same happens again, but this time, the same column reference retrieves another value, 2 and 1592. And this continues, of course, for all the rows. Now, we are simplifying this a little bit just because we don't want to iterate the millions of rows we have in the real model. Now, do we have only the row context when we execute the expression in the iterator during the iteration? Not really. We still have also the filter context that is applied to other table functions in case we use them. Maybe it's not a good idea, but let's try to understand how it works, and then we'll see what could be a best practice to avoid confusion in these expressions. So to see this element of the syntax, I prepared an example where we have two different implementations of the same measure that changes the visualization of the value depending on the selection in the slicer. So selecting the unit, I can see the value in thousands or in millions. So very simple. I didn't implement intentionally these measures in the best possible way because I wanted to introduce in each row a calculation. It's not ideal because the best way would be to compute the value and divide the value at the end. But let's take a look because I needed to show you the difference when we execute something in the row context. So I wanted to use something as simple as possible. So if I look at the definition of the first implementation of this measure, we have a division of the calculation row by row by the value of the selection made in the scale slicer. So depending on what I select in the scale slicer, we retrieve the value that could be 1, 1,000, or 1 million, depending on the selection that we made. Now, it's clearly not ideal to do this calculation row by row, but let's just focus on how this works, because this is for educational purposes only. So if we take a look at how this works, you can imagine that the two column references, these two column references are executed row by row, like we have seen before, by iterating the sales table. However, the second element here, the denominator of the division, is retrieving from the current filter context the selection of the scale column in the scale table. In this case, we are not using a column reference. The syntax is a column in a selected value function, which just needs a column reference to retrieve the value from the filter context. And so in this case, what we get is a single value, but retrieved by the current filter context. You can understand that we are not using the row context, also because we are referencing a column in a different table, scale, while we are iterating the table sales. So if this was a column reference, it would fail because we're iterating sales and not scale. However, the idea, the important element is that the filter context is still available also when you execute an expression that has a row context available. Now, as I said, this could be confusing. So even though we have to compute this calculation row by row, if you think for a moment, the value of this selection is not going to change because of the iteration over sales. So let's say that it's pretty much useless to read this value for each row of sales. It's more efficient and also simpler to read to implement the same calculation using the second the second technique, where we execute selected value only once at the beginning, before starting the iterator, and then we store this value into a variable, in this case factor, and then we reference the variable during the iteration. Again, it would be better to do the division after the sum x, but again, for educational purposes only. Let's try to keep it simple. When we have a row context, just keep the elements that have to be used in that row context and not something else, because it could be confusing when you read the expression to read something that is not actually something that belongs to the current row. And if it is not, if it does not belong to the current row, it would be better to retrieve this value before starting the iteration. So this is the first best practice that we have here. This is not a visual element, I understand, but it's important to clarify the different roles of the filter context and the row context. The filter context filters data, the row context iterates tables. Now, talking about iteration, there is another important element, which is the following. When we iterate a table, the final result of the calculation depends on the number of rows we iterate. Now, this is defined by the filter context, as we said before, but also by the table expression that could generate a table that has a different number of rows and, of course, a different number of columns. But the columns that we are not using are not really a problem. As long as you just reference a table, having more columns in the table is not a problem. If you have to create a table just for an iteration, then we try to keep only the columns that we need. But we have to pay attention, because the different results in terms of number of rows, the different table functions we can use to manipulate tables could produce a different number of rows in the result that could affect the calculation. Let me show you this with an example. In this case, we have other two implementations of sales amount that have to produce different results. You see that in this case, for example, for AdventureWorks and also for Contoso, the number produced by this calculation is different and than the number from sales amount group. And the sales amount projection is always identical to sales amount. Let me show you what these definitions are. So if we start from projection is basically getting a table that has only two columns, but the same number of rows of the initial table sales. So you see that here we are using select columns. We start from the sales table that has all the columns and all the rows visible in the filter context, but we only restrict the result to two columns. We can see this in a graphical way. So if we go back to the whiteboard, my definition of select columns here, so let's just reduce this a little bit. My definition of select columns here corresponds to this sales projection variable. So the sales projection variable contains the result of the select columns, and as you see, it has only two columns of the table sales, which are the quantity column and the net price. So basically we're saying we want to get only this column and this column. So we are reducing the number of columns. Now, is it ideal? Is it necessary? Not at all. But we want to understand how it works. Not at all, because we are not actually duplicating data. We're not actually creating a duplication of the data. Select columns is a way to reference data we already have, but we restrict the columns that can be used in the row context to only the two columns that we want to make it visible out of sales projection. But the number of rows is still 3. We still have the same number of rows, even though now we see that in the table obtained this time, we have two rows that seems identical because they have the same number of, the same value of quantity and net price. The first and the third row are identical. However, select columns doesn't touch the cardinality of the table. So the cardinality of the initial table sales is the same cardinality of the result of select columns. But what happens if we use a different calculation, like for example, summarize? Well, summarize removes the duplicated rows. And so if we use summarize over the same table, now we have only 2 rows as a result. The one with 2, the one with 1 in the quantity, and we removed the duplicated value that you have seen in the third row here. So this row has been removed by summarize. Summarize is a group by sales quantity, sales net price. And of course, now if we iterate this table, we have a different result. We have a smaller number because we are iterating a smaller number of rows. So once again, you have to pay attention to the cardinality of the iterator when you iterate a table. You're iterating the table you obtain with the table function, not the original table. Only when you have a table reference, you are iterating the original table. If you manipulate a table, pay attention to the cardinality that you obtain, because of course the number could be different because the number of rows you iterate could be different. So we have seen that the row context can be described in a graphical way. The current row of a table can be seen actually as a table that has only one row. All the columns, just one row. We will see in a future video that this representation helps us understanding what happens when there is a context transition. And another important concept is that in order to understand the result of a calculation, we have to understand how many rows we are iterating. We have to correctly understand the cardinality of the table that we provide as a parameter to an iterator. Because yes, remember, the row context is only available when you have an iterator, when you have a DAX function that iterates a table. And of course, when you have a calculated column, which is a specific exception to the rule where we have the row context only in iterators in DAX. Let's keep this in mind, and as usual, enjoy DAX.